So I think I'm live. The sound is okay. And we are solving NQueens problem. Let's solve this problem, which is NQueens problem. Here you have N queens puzzle is the problem of placing N queens on a N cross N chessboard such that no two queens attack each other. Okay, given integer n, return all distinct solution to n queens puzzle. You may return the answer in any order. You can return answer in any order. Okay, no problem. Each solution contains a distinct board configuration of n queens placement where q and dot both indicate queen and empty space respectively. Like you have to print like this. There is space q space 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 q q space 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 q space, like this you have to print. In this thing it should not attack like each other, another queen. It should not attack another queen. Also should not attack another queen. Okay, each row should have one queen. Each column should have one queen. No two queens attack each other. And we know how the queens are, like it follows all the directions. So here is it is an example of this problem. How to solve this problem? Like we have like four queens and we have to place it in a four cross row matrix such a way that it doesn't like make attack another queen. How to solve this problem? Yes. So one thing we can be sure is that we can place queens all the places, like in the rows, like here, here, and here, and here. We will have four choices, like n choices. Okay, and we will see um in the columns, like where we can put in the second column where another queen can be placed. Third column, another queen need to be placed. Another queen need to be placed in the fourth column. If it all the coins are what all the queens have been placed correctly, then it is then we can just answer. We just put like q in that places and the answer should be like the answer. If we can't place the queens, then we have to just backtrack properly. Okay, we have to backtrack to previous matrices, and we have to see other examples. Okay, that's how you can solve this problem. And how can we understand this is a backtracking problem? If you don't understand it from the question, you can see the constraint also. Recursion backtracking is similar. Like if you see like it is a controlled recursion, because you have to see whether we can place the another what do you call queen or not. We have to check. So there are some controlled recursion is there, and also pass it by reference so that we do not use extra space. Okay, yeah. So it is solvable by our recursion approach is what backtracking approach. Okay, we'll solve it by backtracking. We will put elements if it can be put if all the elements can be put, then we store it in the answer in the what, in our base case condition. And if it is not put, then we just backtrack it, and what, we just reduce that element. That's how we do this. Okay. Yeah. So yeah. Oh god. Hmm. Hmm. So what we're gonna do is that we are gonna we're gonna make an answer where we will be storing vector of string. Yeah, like vector of string is a strings, yeah, of vector, like a strings of vector. Okay, and we need all or more vectors, so we will vector of strings, like vector of strings will give one, and we need more, so vector of vector strings. Okay, and vector string will contain one solution, that is path, we can say. Okay, which has a size of n, that means n cross n we can think of. Okay, yeah. So then we will make a string s which has a size of n and all with value dots. And then from 0 to n, we will put board in board all dots. Okay, and then we will solve, and we'll call the function solve, where we will give the board the answer n, and also the index, that is row we can or column. First column, second column, we'll fill the all the columns. If it reaches all the columns, then we just answer dot return all that things. Yeah. Hmm. If column is equal to the n, that means we have already got what, the answer. Save it in the answer and return back. And or for row 0 to n, yeah, if it is safe, like, or this is a controlled recursion we are doing. If it is safe to see, like, if we can put like the elements, like if we can put the q, then we will put q in a row or column. will choices we have for rows. First one row, then column, will increase the column if it is done. Increase the column, it would done be by the recursion. If after after we just have all the recursion, you have to just backtrack it to so that we will put same row column with dot, so that means we make it as space. Okay, that's all. Now the main thing you have to understand is how to write the full safe function. Is it safe to put the element the q in the row column? Is it safe? How to know? This is thinkable problem, like how to understand that this is a correct position that we can whether we can put or not. Okay, we'll make checking the upper element. How to check? Int duplicate row is equal to row, duplicate column. So um okay, wait, I need to understand the safe function. So yeah, let us write the code. Let us try to write the code. We need what? We need we need vector of strings as our answer. We need a board. Yeah, board on a path, let's say one path, which has a size of, let's say, n. We have a string s, let's say, which has size n with all the dots. And for int I 0 I less then s dot size, obviously, I think, or path dot size. Mm. It will be n and plus plus. See, what you have done is that made a path which is a strings. Okay, and with a string s with a size of n and all dots, and right, path equals s of I. Sorry, um, path of I equals to s. Okay, like, getting my point. Like, s is a, let's say, string. Okay, s is a like this. S is something like n. Let's say one to. Okay, s is something like all the dots. So s of I, path of I, that is this, is equal to this. This makes sense? This makes sense? Let me show you. This is what I'm talking about. This is what I'm talking about. That path of I is equal to this string s. Okay, string s, path of I is for n. Yeah, I is like indexes, like this is path I1, like 0, 1, 2, 3, and we are putting like this. Okay, now what can we do is that we have made all these dots like spaces, we can say. Then now let us call the solve function. It's called the solve function, where we are passing the column, passing path, passing answer, passing our n, obviously record, and then return our answer, because we are gonna passing answer as our what, as a preference. So let us void solve int column, because we are moving in column. Yeah, then we have a string, because we are dealing with let's say backtracking, and which is changing. We are not just doing anything wrong with that, like column is changing, obviously we are not doing anything with that. And we need answer, which is also passed by reference, because it need to be changed, and int n is there only. int n. Okay, now the base case is that if column, we are moving in column, yeah. So if the column reaches our like the n, that means we have push answer dot push back answer dot pushback path vector string. Got it? Yeah. Okay, and then return. Let's say return. Okay, now we have the path. Yeah, now we are making the path. Let's say yeah, for int row equal, let's say 0, starting from 0, and row less than n, row plus plus. Okay, yeah, row plus plus 0 to n. And it should increase all the rows we are putting queues. Yeah, yeah. Let's say one queue we have put in, one queue we have put. Hmm. Yeah. Now the column, um, to check whether we can, it is safe to put another like, um, like want to put here. Like you have to see that it is safe to put another queue. Like a queen. You have, is safe to put queen or not to check. Yeah, if is safe, row column row column, and we need, I think, a path, and I think n. If it is safe to put q, then we will put q path of row and column was um what q. Okay, now uh now what are you gonna do is that we have put q. Now we will move on to the what we call, if we have put, we'll move on to the, by recursively we'll call the another column. Yeah, column plus one, and path is there, no problem with that. Answer n. You've already got something, and or not, if you have got something or not. Okay, to just backtrack also. So to get another answer. Yeah, so row column equals dot. Okay, yeah. To this is a backtracking approach. Like you have to for like you have passed it by reference, so you have to backtrack also. Yeah, backtrack. Then what are we gonna do? We are gonna like bool is safe function where we have row, column, and string of path and int n. Yeah. So how can we see that whether it is safe or not is by see we have that element like we have the row and the column. We have column like this and the row, let's say 0. Okay. Um yeah. So okay. While row greater equal 0 and column greater equal 0. See, if you put some like something some q, and if you want to see whether we can put or not, is that by checking the these elements like previous elements, because after that there is no element, so this element, this thing cancels out. Okay, so this direction cancels out, all these directions cancel out, and we haven't put any column like q in the column, and one q will be placed in a column, so these things all cancel out, only these three will see. Okay, only these three thing we will see, because yeah, previous element horizontal way, diagonally we'll see if whether there is any q or not. So first thing we are thinking of this direction. Okay, uh, in this direction if you see, um row greater or equals to 0, column greater or equals to 0, yeah, and how to move, like if there is q, if path of row and column equals to q, return false, like 0. If it is not found, then row, like you see, if you want to move in this direction, then row minus minus, row minus minus, column minus minus, row minus minus, column minus minus. Yeah, we have checked in this what in this direction to make it, let's say row 1 equals row, and column 1 column 1 equals column, because it is changing, that's why we're doing. Now again we'll make row mm, we have row 1, so row, because it is changing, row and column is changing here. Okay, so we'll make again row equals to row 1 and column equals to column 1. Okay, now we'll move in this direction, that is column minus minus. So we need column only. Why? Nah, we need also this. While um column greater equals to 0, because we are minus minusing. Yeah, and row is not changing. So why would why would I put like this? Okay. If path of row and column equal to q, then return 0, and then column minus minus. Okay, then again row equal with 0 1, don't need to, because it is like the column was column 1, while like we want to move like this, so it is like column minus minus row plus plus. So column greater equals 0 and row less than n, if path of what row and column equal q, then return 0, else row plus plus and column minus minus. Pretty nice, pretty simple. If any of the cases we haven't found any q, then return 1, that means we have found. What? um yeah, why right, right of 38. Yeah, okay. Mhm. It does give me a solution, but better optimal approach we can think of on this problem. We can think of a better approach on this problem. Okay, if you see, like here, if you see big of n, let's say, if at worst case big of n, it is also big of n, a big of 3n, let's say, and it is for loop is moving like n times, so big of n, and inside there is also is a function big of n. So big of n into big of 3n, and also there is a recursive function which is say 4 choices in rows, then one is put, then again with some little choices, because some cases will be cancelled out, or we can say safe or not. Let's say it will be like um I think the time complexity here will be um it would be like we have to see now. We have four choices. Put Q recursive tree. Any one them we put can't put in these directions. Two choices. Worst case, three choices. Let's say here you put then two choices like n factorial 3 to 1 okay. And number of choices and do number of like in um see you see big of n, yeah, just the function. Nearly n factorial into n, like n factorial, big of n factorial mostly. We have better approach, which I'm gonna show. So to 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 uh not do this type of loop like while loops and big of n big of n big of 3 and to minimize this problem, we can do one thing for sure is that we can make a hash map. Yeah, to check that this direction, like left row, this direction, and also these directions. That is horizontal, like sorry, diagonal, upper diagonal, lower diagonal. So we need three things: um, vector, int, uh, let's say row, left row, which has a size of n, and all elements as 0, and also upper diagonal, which has a size of, let's say, 2 multiplied by n minus 1, and size 0. So lower diagonal, which is also multiplied by n minus 1. To remember this, okay, and all this past left row, upper diagonal, and lower diagonal. Okay, so we can like uh, and pass it. Yeah, don't need that address. This thing we have to just copy, paste, and paste. Just thing and thing. All thing is done. Is safe function is not required. What we can do is that we can check if left row um let's say we have placed q here and q here. Yeah, so let's say row 0 is placed, 1 is placed. Again, if you want to put like row, I think 0, can't place it if not 1, then again the what, let's say lower dia, like this. All this will be what, row plus column, add it. If it is 0, then all good. And what, upper diana, upper diameter, which will be n minus 1. Okay, n minus 1 will be like n minus 1, and I think column minus 1, minus 1, column minus 1, n minus 1 plus column minus 1. is equal to 0, then we can just put it as L, and then if we can make these things 1 also, after we have already got it. 1, 1, 1. Here you have to change with left row, lower, upper I think. We don't need this. All this is done by a hash map. So remember this, that we have used a hash map to solve this type of problem. Okay. Um, okay, got it. Um, n minus 1 plus column minus row. Pretty big solution. First one. We have to backtrack also, yeah? Where? Same thing, bro. Turning back, we have to backtrack now. So you have to make it 0 also. So yeah, make it 0, 0, 0. Let's see whether it is solved or not now. Yeah, it is solved. Memory is efficient. So the if you see the the term complexity is same, but the space complexity is changed to big of n. And in the previous solution, we have n square space complexity. That is the difference. Say function is lots of loops we are doing, which is not done here. Like big of n, big of n, big of n, 3n, big of 3n, let's say. And here it is not. By using just a hash map, like we can say a vector, where we are storing like the diagonal and left all these things, left row, diagonals, lower diagonals, upper diagonals. Pretty simply we can solve this. 2 to the power n minus 2 into n minus 1 is the size, and what we are, if it is what lower diagonal, then row plus column, and if it is upper diagonal, then row n minus 1 plus row minus column. Okay, pretty simple. Hope you like this video, and this is for